Welcome everyone. I am going to give you a tutorial on how to use gtburst to analyze Fermi-Lat data for gamma ray burst. So I assume that you have installed Fermi tools using Conda and that you are in the Fermi environment. From here you can just type the name of the tool, gtburst, and a canvas window will open, which is the main window. At this point, there are several things you can do. You start from the file menu. There are several ways to start, either loading data from a directory if you have already downloaded the dataset, or if you are starting from scratch, you can start by downloading a trigger dataset. From the download data window, you can choose to browse triggers to see the list of GBM triggers. A window will open showing you all the gamma ray bursts. They are listed, as you can see, with the oldest at the top, but you can reverse the list by clicking on name. So today we can, for example, analyze bright burst 1901-14C, which is the burst also detected by MAGIC. Okay, so 19. Okay. Here it is. Okay, then you click done. All the fields are automatically filled, and you want to download LAT data. Continue, and we select the default 10,000 seconds after the trigger, 10,000 seconds of data after the trigger. Okay, you can see on the console, on the window, all the commands that have been run after the download of the data. A small window will open showing you which data are available, in this case the LAT, and the off-axis angle with respect to the LAT boresight. Then you click OK. Okay, this is the light curve, so the event being in time, where 0 is the GBM trigger time. You can see that the burst is clearly very visible in the LAT data. You can also see the evolution of the burst in the LAT field of view by selecting make a navigation plot. As you can see, the zenith angle of this GRB was 92 degrees, and its off-axis angle is 68 degrees. So these two plots shows the evolution of the zenith as a function of time and the evolution of the off-axis angle. So this is important to note that the LAT, the burst was actually quite off-axis at the time of the trigger, and this will determine the way we analyze the LAT data. Okay, so now you can close this window and you can proceed with the make likelihood analysis task. These are the parameters, some of the parameters that you can change. The 12-degree radius is the default, and is in most of the cases is an okay choice. You can select different type of IRF. Again, the default is a good choice. Zenith maximum 100 degrees is also okay. For this burst, we want to analyze at least 200 seconds from the trigger time, and the energy range from 100 MeV to 100 GeV. It's fine. Okay, the important thing is that when you are analyzing bursts with a very large incident angle that they are exiting the lat field of view, the best strategy to adopt is to select on events instead of select on times. And then you run. When this step is done, two plots open. On the left is the sky map with all the events in your selection, and on the right is their energy versus the arrival time. And as you can see, these canvas are interactive, so if you choose the event on the right hand plot, they'll show you the direction and the location of the event on the sky map. Okay, at this point we can proceed to the next step that consists in building the XML file to be used in the likelihood analysis. So the first parameter is the particle model, which isotropic template do we want to use. You have a few choices. The default one is the most of the cases is the correct one. As for the galactic model, we usually select a template with a fixed normalization and a power law 2 for the source model. For the FGL, you can either choose to include all the sources in the FGL within the ROI, or only the ones that are bright enough to actually contribute to some event. So we select this one, and then we hit run. As you can see here, one source has been selected from the 4FGL to be included in our ROI, in our model. At this point we can proceed to the next step. Here we don't really have to select anything, we just click run, and the program will show you the current selection for the model. The GRB is on top with a spectral component equal to a power law 2 here. The isotropic template has a normalization set to 1, and yeah, that's one. And finally, the galactic template has a fixed normalization. So then done, and next step. So here we select the parameter for GT-like. The first one is the value of TS in order to compute flux value. So for a TS below this number, an upper limit will be instead computed. We can choose to select to use a GT find source to optimize the location of the burst. This will add an extra step. Now we don't want to do that. For binned likelihood analysis, we can also choose to produce a source map and show the source map in the display. Again, we're not gonna do that now. And if we want, we can also obtain XPEC file for the GRB, which means a PHA file, a background file, and a RSP file obtained after the GT-like step that can be used in XPEC analysis. The likelihood time for GRB, we most in all the cases select unbinned analysis. This is the confidence level in which upper limits are computed, and these are the minimum and maximum energy range for the flux or upper limit computation. So after selecting this parameter, we hit run. So this step will take quite some time, so it's a good time to go and grab your coffee and come back in a few minutes to see the results of the analysis. Okay, I jump right to the end of the analysis when the results are shown. 3 windows are open. This one showing the spectrum with the red line, the GRB spectrum. This one showing the residual counts minus model divided by the model. And this one contain the parameters of the model that best fit the data with the value of the TS. As you can see, GRB 1901-14C is the denominated source. Okay, the last thing I want to show you is this one. So in the directory where you run the analysis, several files have been saved in the process. Those include the fits file containing the sky map, the exposure map, the lifetime cube, and filtered events that have been used in the analysis. The XML model include in particular this one, the LikeRes, contains the best fit parameters. And finally, quite important, is the gtburst.log that contains all the steps in the analysis with the output and the results of this analysis at the very end. So this is useful for if you want to cut and paste numbers from here. Okay, this concludes this tutorial. Thanks for listening and have fun with gtburst.